Hello and welcome to Lesson 2, Graph Simple Rational Functions. Our objectives are to be able to identify the vertical and horizontal asymptotes, to determine the domain and range, and to be able to graph. Now you'll notice I have 3 different graphs here. These are all graphs of rational functions. They can get a little bit crazy, but in this lesson we are just going to be graphing simple rational functions. So we'll just be graphing this type of graph here on the left with just the 2 different legs. Let's get started. Let's start by looking at the parent function. The parent function is 1 over x. That's the parent rational function. Very similar to y equals x or y equals absolute value x. And we've even looked at parent functions with quadratic equations. So today we are going to start rational function graphing. First, let's go ahead and graph this. What we want to do is pick some points in order to help us graph this. So what I'm going to do, and this is just because I know what this graph looks like, and you just recently saw, so I'm going to pick points that will enable me to graph it appropriately. So I'm going to pick 0.5 or 1/2 for x. And then I'm going to pick 1, and then 2, and then I'm going to pick some negatives the same way. So I'm going to pick negative 0.5, negative 1, and negative 2. For each of these x values, I'm going to plug them into my parent function. So 1 divided by 1/2, or 1 divided by 0.5, is going to give me 2. 1 divided by 1 is 1. 1 divided by 2 is 1/2. Now we're going to have the same numbers, only negative. So we're going to have a negative 2, a negative 1, and a negative 1/2. Now let's graph these numbers. So here's 0.5 and 2, 1 and 1. And let's see, our last point here, negative 2 and negative 1/2. So I've graphed these 6 points. And how this looks, let's go back and compare it to what we saw here. Notice how these legs curve, and then there's these dotted lines. These dotted lines are called asymptotes. And what that means is that this tail here, for example, is going to get really, really, really close to that dotted line, but it's never going to reach it or cross it. Same thing with the tail here. It's going to get really, really, really close, but it's never going to reach it or cross it. And that would be the same for this other leg here. So we have a vertical and we have a horizontal asymptote. These are our guidelines to help us to draw these legs. So if we can find these vertical and horizontal asymptotes, it makes it really easy for us to graph these functions. Let's go back to our parent function. Since it's our parent function, we have no transformations, and that would mean that our asymptotes are going to be 0 at this point. And you'll see why that is in a minute when we start looking at transformations. So what I'm going to do is I'm going to put in a dotted line here for my horizontal asymptote, and then I'm also going to put in a line up here for my vertical asymptote. And these will be my guide to help me when I draw my legs. Okay, now let's go back and finish drawing our legs. Well, I know that I'm going to come up here and get really close to this asymptote, but I'm never going to reach it and I'm never going to cross it. I'm just going to get really close to it, to both of them, to the vertical and the horizontal, but I'm never going to cross it. Same thing with the one down here. I'm going to draw it really close, but I'm not going to cross it or reach it. Okay. Now the second thing I want to do is go ahead and write the equations of our horizontal and vertical asymptotes so we know those. If we are drawing a horizontal line, we draw a horizontal line where y equals 0. When we draw the vertical line, we draw a vertical line through the point when x equals 0. So it may seem a little backwards to you because horizontal represents the x-axis and you might think x. But in order to draw a line that's horizontal, we're actually drawing it through the point y equals 0, and the opposite with the vertical. Now let's go ahead and look at our domain and our range. Well, our domain, if you think about our domain, it's all the x values that work. Well, every x value is going to work to the right here, but then as we get close to this point here where x equals 0, remember we're never going to reach it because there's an asymptote here. Same thing coming from the other side. All these values out here towards negative infinity work great, but this orange leg here is never going to hit where x equals 0 because it's never going to cross the asymptote. So for our domain, we can say all reals, and I'm going to use this cursive R as an abbreviation for all reals, except 0. And remember that when you looked at the excluded values on rational functions, you always looked at the denominator to see what made it be 0. Well, when x is 0, that won't work. And it's not a coincidence that our domain is everything then but 0. Okay, let's look at our range. Our range is the y-axis, up and down. Well, notice that this leg is going to go up to infinity forever, and this leg is going to go down to negative infinity forever. However, there's a break in here where the asymptote is. So once again, our range is going to be all reals except where y equals 0. Okay, now let's look at some transformations. In a simple rational function, our transformations will look like this. We'll have an a, which will represent a stretch, or a perhaps if it was a fraction, but we won't see that as a fraction, so we'll call this a stretch. We may also have a negative in front of here, which would cause our legs to reflect. And then our h here, remember it's the same as before. H is in here with the x, so that's a shift left or right. And then our k on the outside is a shift up or down. That goes along with our y. So let's just put this out here. If we have a negative in front of the a, we know we have a reflection. And if we have an a value, and we'll just say the absolute value of a because we're already dealing with the negative up here, if the a value is greater than 1, then we are going to have a stretch. Now we also have an h. So if we look at our h value, that's going to be a shift left or right. Now remember, anytime it's in an expression with x, it's always going to shift the opposite direction. For example, if I had x minus 2, that would be a shift right of 2. Finally, we have our k value, and our k value is a shift up or down. And if it's a plus 2, it shifts up, and if it's a minus 2, it shifts down. So it is not the opposite because it relates to y, and y is on the other side of the equal sign already. Okay, let's now look at how these transformations will affect our asymptotes. It's very nice because it's pretty straightforward here. So with our vertical asymptote, remember that it was x equals, and it was x equals 0 in our parent function. Well, here, now we have a transformation to the x, which is h. So our vertical asymptote is always going to be what the h is. Same thing with horizontal. In our parent function, it was always y equals 0, but now it's going to be whatever the k is. Our domain is going to work the same way it did before. It's going to be all reals except whatever our asymptotes are. So it's going to be for our domain all reals except h, whatever h becomes if it's not 0. And our range will also be all reals except k. It's going to be very important that you write this slide down because this will really help you figure out the puzzle of how to graph transformations of a parent function. Let's go ahead and try 2 examples. Okay, let's look at our asymptotes first. So what's happening in here, x minus 3? This is saying that we are going to shift to the right 3. So instead of having a vertical asymptote through 0, our vertical asymptote is going to go here where x equals 3. So I'm going to draw that in. Let's look at our vertical asymptote. This is a plus 2. So that means that our graph is going to shift up 2, which means our asymptote is up 2. Now let's go ahead and write these equations. So this equation going through this point here where y equals 2 is just that. It's going to be y equals 2. And then this one going here, where x equals 3, would just be x equals 3. So those are the equations of our asymptotes. Those are very important that you plot first because they are our guidelines. We'll do our domain and range last. Now when I pick points, I'm going to pick them strategically. I'm going to pick them around where the asymptotes cross. So I'm going to pick x values to the right of where they cross and to the left because I know that my legs will be in one of these four corners. So if we look at this, perhaps I want to pick points like 4 or 5 or 2 or 1. So let's go ahead and try some of those points. Now all I have to do is plug them in. If I plug in a 1 here, 1 minus 3 is negative 2. So this is negative 1/2 plus 2, which gets me 3/2. Now let's plug in a 2. 2 minus 3 is negative 1. So 1 over negative 1 is just negative 1, and negative 1 plus 2 is 1. And you're more than welcome to put this in your calculator and use decimals if that's easier. 4 minus 3 is 1, and 1 over 1 is just 1, and 1 plus 2 gives us 3. Now let's do 5. 5 minus 3 is 2. 1 over 2 is 1/2, and 2 plus 1/2 is just 2.5. And I could write this one as 1.5 if that's easier as well. Now all we need to do is plot our points. Notice that I only picked 2 points on each side of the asymptotes. And that's okay because all I'm really trying to do is figure out where my legs are. Which quadrant are they in? Because I know what shape they're going to form and I know based on these guidelines how they're going to go. So really 2 points is plenty for me to get a good idea of my legs here. So there's 1, there's 2. So 2 on either side of where the asymptotes cross is plenty for graphing these by hand, a rough sketch. All right, finally, let's figure out our domain. So if we remember what we said before, we said that our domain would be all reals except h. So what is h on this? Well, h is always down here next to the x, so all reals except for 3, and it should match this asymptote, right? Our domain and range are going to always be all numbers except for where the asymptotes are. So our range is then going to be all reals except k. And k is this 2, which is where we placed our asymptote. And now we're finished with this problem. Let's do one more example. Okay, here we are. Let's go ahead and plot our asymptotes first. Remember, those are our guidelines. So our first one we have is x plus 2. Remember, that's actually a shift to the left, too. So I'm going to put my asymptote here at x minus 2 because everything starts at 0. Over here, our minus 1 means we shift down 1. So our whole graph shifts down 1. So I'm going to put my asymptote down there. Now I just need to write the equations of these asymptotes. Well, the horizontal one here is where y is equal to negative 1. So y equals negative 1. The vertical one is where x is equal to negative 2. It helps to see them visually first, and then you'll make sure that you write the correct equation where the horizontal is y and the vertical is x. Now let's pick some points. Just like before, we want to pick points that are on either side of where the two asymptotes cross. We want to pick x values like negative 1 and 0, and negative 3 and negative 4. So let's go ahead and do that. Now let's plug the values in. Plugging in a 0, 0 plus 2 is 2. Negative 4 divided by 2 is negative 2, and negative 2 minus 1 is negative 3. Negative 1. So negative 1 plus 2 is 1. Negative 4 divided by 1 is negative 4. And negative 4 minus 1 is negative 5. Now let's look at negative 3. Negative 3 plus 2 is negative 1, and negative 4 divided by negative 1 is positive 4. 4 minus 1 is then 3. Last, we have negative 4 plus 2 is negative 2. Negative 4 divided by negative 2 is positive 2, and 2 minus 1 is just 1. Now we're ready to graph our points. Okay, I've got all 4 points graphed, and this is all I need because remember, I just need to know what quadrant my legs are in because I know the shape that it's going to form. So there's 1, and there's 2. And this is just a rough sketch, remember, so that's close enough. Now we can look at our domain. Remember that our domain is going to be all reals except this value here, our vertical asymptote, which is negative 2. And then our range is also going to be all reals except, remember our range is going up and down. Well, we can go up and down forever except for this horizontal asymptote at negative 1. To help you do this better, make sure that you keep this very organized in your notebook and that you follow these problems step by step. Find your asymptotes, plot them, find some key points, plot those, and draw your legs. And that concludes our lesson today on graphing simple rational functions. So hopefully at this point now you can identify the vertical and horizontal asymptotes, you can determine the domain and range, and you can graph by hand.